Hello everyone, I am Manoj DK of DS2A section GM University, Davangere. Now I am here to present my second operating system assignment on FCSC. First come, first serve. Now I will explain the introduction of this project. Introduction. CPU scheduling is a case function of a modern operating system. It has directly impact system performance, process efficiently, and overall users experience. First come first serve in the simplest and one of the oldest method. In FCSC scheduling, the processes are executed in the exact order of their arrival time. Think of it as it was queue of a ticket counter. The first person who arrived first served first, and the last person waits until all the before them are served. FCSC is a non-preemptive, meaning once a process started execution, it runs with until completion. Even if higher priority tasks arrive, the main advantage include simplicity, easy implementation, and fairness of every process get its turn into order. Now I will explain the experimental setup for this implementation of FCSC. To create reliable FCSC scheduling simulator, the following steps was utilized. First, hardware configuration. Processor Intel 5 and 10 Gen, RAM 8 GB, storage 500 GB and SSD. Software configuration. Operating system Windows 11 64-bit, and programming language is used is C programming. Input parameters. These are the input parameters: process ID, unique identifier for processor, arrival time, which process arrives in the queue, and burst time, CPU execution required by the process, and output matrices, completion time. That means these are the desired outputters. Completion time means finish of execution. Turnaround time, time spent by the system, and waiting time, time spent by the waiting time. Implement, Implementation steps. Step 1, input, enter the number of process, and next, enter the process ID, arrival time and burst time. Step 2, sort the process, arrange the process by arrival time. If two numbers are same arrival time, keep it in order. Step 3, calculate times. If the CPU is idle, more current time or arrival time. Completion time is equal to current time plus burst time. Turnaround time is equal to CT minus AT, and waiting time is equal to TAT minus BT. Current time or start time is equal to complete time. Step 4, to calculate the average turnaround time, which is equal to sum of all TAT divided by number of process. Waiting time, it is equal to sum of all TAT divided by number of process. And this is the flowchart. Now it is the code. There are mainly four libraries, standard libraries used to implement the FCSC. First one, IO stream and vector and algorithm, and IO main IP. These are the This is the code. This is the Gantt chart of the uh, three processes. That means P1 arrived at 0 time and completed 6 time, and P2 started at 6 time and completed at time 10, and process 3 P3 is arrived at started at time 10 and completed at time 12. Observation from this project or assignment. First one, waiting time depends on arrival time. If the FCSC first process gets the CPU immediately, if it has arrived later, the process must be wait for the previous process to finish So waiting time increases for later arrivals. And convey effects. If the first process has a long bus time, it delays all other process even if they have shortest bus times. This increases average waiting time and turnaround time. CPU idle time. If the no process arrived at CPU stages idle until the process arrives, the properly spaced arrival time can reduce the idle time and improve the efficiency. Average waiting time and turnaround time. FCSC easy and fair, and if bus time has similar and FCSC works well. Comparative evolution. The FCSC works differently for different data sets. Long first process increases waiting time, while eventually burst time keeps waiting time low. For example, consider P1 process P1 P1 2 3 and arrival time 0 1 2 and burst time 6 4 2. Then the desired the output or the output outcomes are uh, bus time complete time of the P1 process 1 is 6 and complete time of the 2 process 2 is 10 and complete time of process 3 is 12 and turnaround time of P1 is 6 to P2 is 9 and P3 is 10 and waiting time of P1 is 0, P2 is 5 and P3 is 8 and the average waiting time is equal to 4.33. That means sum of all the TAT divided by number of process and average turnaround time is equal to uh, 8.33 seconds. Lastly, I would like this. Lastly, I will explain the conclusion of my assignment. The first come first served scheduling algorithm is one of the simplest and easiest CPU scheduling method to implement. It executes the process in the order of arrival time, makes it fair and predictable. FCFC works efficiently when all the processes have similar burst time. As waiting time remain low, the CPU is used efficiently. However, if long process arrives first, it delay all other processes, leading to higher average waiting and turnaround times. FCAC is the simplest and fair, but it may delay later process if burst time vary. It is not suitable for real-time systems where tasks need to quick execution. Thank you.